Hey guys, who is ready to do some graphing today? Whoop whoop. Okay, so we are going to be graphing our quadratics, and you already know the basic shape of quadratic because we've talked about it. So a quadratic looks like the letter U from the alphabet, and we know that it can smile at us and point up, or it can frown at us and point down. We also know that we can graph it if we know the vertex. We've already learned vertex form, and remember, vertex is either the lowest point or the highest point. And we know that there is an axis of symmetry that goes down the middle of that parabola so that it mirrors itself on either side. Okay? So when we go to graph these by hand, it's important for us to kind of think back to know these things. Okay? So on this first one that we look at, we notice it's in standard form, okay, because A, B, and C are all on the same side of the axis. So A is 1, and B is 2, and C is -3. And so we know that we can find our vertex, okay, and remember our vertex is a point, x comma y. So we know we can find the x point by following the formula -b over 2a. -b means you're going to take the opposite of b. So the opposite of +2 would be -2. And then the bottom would be 2 times a, which is 1. And that gives me -2 over +2, which simplifies to -1. So the x point on my vertex is at -1. Now we need to find our y point. And the way we find our y point is we take this -1 and we plug it in where both of our x's are. So we can find that point by putting -1 in parentheses and squaring it, plus 2 times -1 in parentheses. Remember, it's good to put parentheses around things when we're plugging them in so that we get all of our signs right on our computer. -3. So if we type it in exactly like that, we should end up with -4. So my vertex is happening at -1 comma -4. So I'm going to go graph that over here. So I go to the left one and down 4. And there's my vertex. And I know that my axis of symmetry goes right down the middle through my vertex. So I'm just drawing in this dotted line. And remember that the axis of symmetry, the equation of that line is x equals -1. So now what we need to do is we need to pick an x point from either this side of the axis of symmetry or this side of the axis of symmetry. Because if we get one point, then we know we can match it with the point on the opposite side of the axis of symmetry. The easiest x point to pick would be 0. Okay, so that's what we're going to pick. So let me erase all of that. So if I put 0 in for x, I get 0 squared plus 2 times 0 minus 3. I know 0 squared is 0. I know 0 times anything is also 0. And then I'm subtracting 3. So when I plug that 0 in, I get a -3. So when x is 0, my y value is -3. That's how I find that point. So I'm going to go to 0, -3, which is right here. And then it's 1 away from my axis of symmetry. So I'm going to go 1 away from my axis of symmetry on the other side. And I'm going to put my other point. And 3 points is enough to graph a parabola because we already know the shape. Okay. These are technically rough sketches of our parabola. Okay. So let's look at the next guy. Hopefully you recognize that this is in vertex form. And remember, our formula for vertex form is y equals x minus h quantity squared minus k. And so what that means, plus k, What that means is that we can notice that this is matching this, and our k value is matching this. Hopefully you remember that our h is always the opposite of what we see in those parentheses. So since we see a positive one, that means our vertex, x point, is a negative one. And our k value gets to be whatever k value we see there. So we don't have to change the signs for that one. So this has a vertex at -1, -4. It's the same as the vertex on the other one because, believe it or not, these are the exact same equation. They're just written in two different forms. So my axis of symmetry is still x equals -1. So I'm going to draw my little dotted line through that guy. And I'm going to pick 0 again and plug it in and see what it gives me. So if I put 0 in for x, I get 0 plus 1 quantity squared minus 4. 0 plus 1 is 1. So I've got 1 squared minus 4. And 1 squared is 1. 1 minus 4 is -3. So that gives me the same point I got earlier, 0, -3. So the point is, we can have two different equations, different looking equations, but they actually graph the same parabola. How crazy is that? All right, so those are two examples of how we could do it by hand. But since we get to use calculators in real life, let's use Desmos to graph these two. Now, the first thing I want to point out on this one is we know that this parabola is going to frown at us because it has a negative in front of our x squared term. So it's always kind of good to know when we start, hey, is that parabola going to smile or frown at me? Just to make sure that when we sketch it, we didn't type something into Desmos wrong because we were in a hurry or something, okay? So -x squared is what we're going to start with. See, it's already pointing down. And then we have a plus 6x minus 12. All right, so there's our parabola. When you graph in Desmos, if I want to know what the vertex is, I just have to click it and it pops up for me, 3, -3. So I'm going to go back over here and I am going to graph 3, -3. Okay, that means that my axis of symmetry is x equals 3. So I'll just sketch it in right there. And then if we want to know what some other points on our parabola are, we can click this gear icon. So I'm going to pause the video and make you do it. And when we click the gear icon, we want to click this little table. And that table will spit out a list of values for us. Now, it always uses these same 5 numbers, but we know that our vertex was at 3, -3. So we're going to click below the 2. We're going to type our 3 in. It's just nice to see that, okay? So we can use this point right here. 2, -4 is this point that it put on the graph for us right there. 2, -4. So let's go do that point on our graph. So at 2, -4, it's right here. And that's 1 away from our axis of symmetry. So let's go 1 on the other side to get our mirrored point. And then we can just sketch in our parabola. Now, if you happen to have a graphing calculator, a TI-84, then after the last example, I'm going to put a note in the videos that you can click, and you will see that there's a link that you can, for a short video you can watch that tells you how to do this with a TI-84. Okay, so let's go ahead and let's go back to Desmos and type in this one. It looks a little bit different. Negative on the outside, it's still going to point down and frown for us. X minus 3 quantity squared, that's how we say that. So we'll X out of that table and we'll go over to our negative sign, and we will do parentheses, x minus 3, close them, and square it. So I always want to go back and double check that I typed that in right. So x minus 3 quantity squared. Yep, looks good. So here's our vertex at 3, 0. So we'll go ahead and put it on here. And then if we want to see some more points, we're going to do the gear icon and the table icon. And it shows us it always shows us 5 points. And I want to point out, I said it always shows us these 5. So it always goes from -2 to 2. And if we ever want a point past that or on either side, then we have to type that in. So when I type in that 3, it goes ahead and gives me my vertex right there. So let's take this point at 2, -1 and put it on there. So 2, -1 is right here. Okay, I'm going to dot my axis of symmetry. It's 1 spot away from the axis here, so we're going to go 1 spot over here to graph our matching point so that we can draw in our parabola. All right, check out the note, and you can watch the video if you have a TI-84. You do not have to watch the video if you prefer